point isn't for me to have you crunch a whole bunch of math problems. The point of it is for you to learn what it's all about. We do have to crunch math, but we're not wasting time on doing integration. So there are, so I'm going to, well, let me just take this one off. Could leave that there. Actually, maybe I should leave it here so that thing doesn't keep hitting me. Get rid of this one. So there is a difference between center of mass, center of gravity, and the centroids. And I know whenever I ask this question, like some of you know, but most of you really didn't put the thing together. So there is, this one won't work. There's center of mass, there's center of gravity, and there's centroid. And there are two different types of centroids. There's a 2D centroid and a 3D centroid. So there are really 4 different things that we're looking at. They all are based on different components. So what do you think center of mass? So we're talking about bodies, right? So what characteristic of a body are we dealing with when we're talking about center of mass? Karen, what do you think? Center of mass.
Probably
Mass. Mass. Good job. So what we're thinking about is mass. Is weight mass? No. What is weight? Mass times g, right? So it's a force, correct. So when we're dealing with center of mass, we're only interested in the mass of the body. Okay, Eric G, what about gravity? Center of gravity, what do you think we're dealing with? Force of gravity, and tell me what that is. That's a physics. Force of gravity, you're not a physicist. You're an engineer. Force of gravity is something that a physicist would say, right? Force of gravity. Well, what the hell is force of gravity? What the hell is force of gravity? Right, weight! Can't we just say weight, right? Weight. Weight. So these two, they're probably going to be in the same place because the center of my mass is probably the same as the center of my gravity, or it is, right? And that's where the physicist would know the answer to that part. Okay, so now let's think about centroids. Wes, what characteristic of body are we dealing with when we deal with two-dimensional?
What characteristic?
Yeah, or you can just think of centroids. What's centroid based on? It's not based on mass, it's not based on weight, it's based on, maybe?
Physical.
Area. It's the physical characteristic, so it's based on geometry. Centroids are based on geometry, so 2D would be area. And what would 3D be, Wes? Yes. So this is what we're dealing with. So, let's say the point over here is my origin. Right here is the origin, and this is x, and this is y. Okay, y, x. And I want to find the center of gravity of all of you. Where do you think? Jill, stand up. Where do you think the center of gravity would be of everybody? Look at where everybody's located. Look at their weights. Look at how many people there are. So move in the coordinate that you think would center everybody's gravity. So you have to look this way in the x, and you have to look in the y as well. Okay, well, let's see. There's 6 people in front of you. 1, 2, 3, 4, 5, 6, 7, 8, 9 people behind you.
go back.
Go back. Good. Now let's see. There's 1, 2, 3, 4. And there's 1, 2, 3. So you're not including yourself. 1, 2, 3, 4, 5 people on this side. And there's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I would say right about there. What do you think? Everybody? Okay?
Good.
Good. So mathematically, how could I have solved that problem? If I wanted to find Jill's location in this direction first, how been able to calculate where the center is.
You measure the distance from one side to the other.
Measure the distance from one side, not just to the other, because maybe it's 25 feet, but what distances do I need to know? To each of the people. So I would say, okay, I would sum up all your weights and all your distances and then divide it by the total weight. The total weight, right? Because I'm doing weight. So I would take Kyle's weight times 2 inches, no, 2 feet, right? Plus Paul's weight times 7 feet, plus Haley's weight times 8.5 feet. And I would add everybody's weight in, multiplied by the distance, and then I would divide it by the total weight. So isn't this the equation? I do the sum of the weights times the distances divided by the sum of the weights. And now let's do this in math, right? It's equal 1, I is equal 1 to n. This is I. Did I just do that right mathematically, the way? So it's the weight of Kyle times the distance to Kyle plus the weight of Paul plus the distance to Paul plus everyone, and I divide it by the total weight of everybody. And what do I get? I get that x bar to that center.
Yeah.
Oh, I should put,
Shouldn't it be n weights?
no, I'm adding them all up.
To the coordinates where you are, where you.
Yeah, wherever the point happens to be that it's referencing from, and we're going to reference it from the origin. And then, so this was the x direction, and this was the y direction. How would I find the y distance? What would it be? Mark, we're up to you.
It'd be the sum of the weights in the y direction and their corresponding distance from the origin.
Right? And then divided by
The total weight.
sum of the weights. So you're taking the weights times the distances divided by the total weights, and you can see geometrically you're going to get, right? You're going to get dimensional analysis, you're going to get a distance. Does that make sense?
It's like a non-zero force.
Totally, that's what it is. It's your moment times your distance. I'm sorry, it's your moment divided by your sum of the forces, right? Doesn't this translate? This translates to the sum of the moments divided by the sum of the forces,
Yeah.
right? It's the same thing. So this is great, we've already done this, right? So let's look at those 4 components again. Which component did we just do a problem for? Center of mass, center of gravity, centroid of area, centroid of volume. Center of gravity, right? We just did center of gravity. We used weight and we summed up the weights times the distances. So what do you think the equation would be when we're trying to find the center of mass? Again, I'm trying to find the x distance. So what do you think I would do? Andrew? So if we did center of gravity, we multiplied the weights times the distances divided by the total weights, and we got a distance. What if we're dealing with masses? What would you do? I'm not going to write these i's again, okay? Sum of the masses times the distances divided by sum of the masses. It's kind of weird.